using your calculator a whole lot. So you want to get your calculator out during class so you can kind of run through some of these things with me. So to begin with, on this, on the first page of 3.2, I'm actually not going to do much with that. I'm going to move on. That's more or less showing you how the compound interest formula develops out of the simple interest formula. So I'm not going to really do too much on that. I want you to go to the top of page 2. And what happens, the way our book does this is we've already learned this compound interest formula. I would highly recommend everybody write this down right now, this formula that I've got highlighted up here in blue, because you can use this format if you want to. The textbook is going to condense this a little bit, and instead of putting the R over M, they're just going to put I, and instead of putting MT, they're going to put N. You can still use the formula that I went through last week. That's what I would do, because to me it's a little bit more clear. Anyway, so let me kind of go through what everything means on the compound interest formulas, and we'll go through some examples. The only thing that's a little bit different on this section will be we have to use logarithms a little bit in solving those things, but it's fairly straightforward how we do this. So A is the amount after interest, like we've already talked about. P is the principal. That would be the amount that you deposit. We call that the present value sometimes. Okay, and then A is called the future value. And R is the interest rate. This part right here that you want to pay attention to is I is equal to R over M. So when you see I in this formula, you take the interest rate and you divide it by the number of times that you do interest. Okay? A couple of things, you don't have to write this down, but I just want to kind of remind you of this. You can write this down if you feel like you need to. So like if I said compounded annually, then that would mean M is 1 in that formula. That would mean you do interest one time during the year. Okay, we already talked about some of this stuff. If I said semi-annually, that would be 2. That means every 6 months. Okay, so in that formula, you want to know that. If I said quarterly, quarterly is M is equal to 4. So that would mean that you do interest 4 times in a year. And then if you did monthly, this is pretty much what you would see, is monthly is the most common, then M would be equal to 12. So in this compound interest formula, when you do I is R over M, just use the interest rate that's always given to you, and then M is the number of times you do interest. You're always generally going to do annually, semi-annually, quarterly, or monthly, okay? You could also do daily, and daily, what we usually do is a 360-day year. Okay, that's what I'll do. That's what our textbook does, is that then. Okay, and then what we have, we've already looked at this formula. We looked at the continuous compound interest formula. So if you have any problem and it says anything about interest being done continuously, then you have to use a different formula. So you've got compound interest formula, A equals P times 1 plus I to the N. Then you got continuous compound like that. One of the key things in these problems is which formula to use, how to get everything set up, and then all the arithmetic you're going to do on your calculator anyway, okay? What's that? I'm sorry? Daily 360 is what we typically use, okay? And they will pretty well tell you, like when you're working homework and stuff out, they're usually going to say use a 360-day year. Okay, like on the final exam, I'd say the same thing. If that showed up, I would say use a 360-day year. Okay, that's a common business practice. Yes.
Is there a reason? Excuse me. Is there a reason?
Because when you go back in time before we had calculators and stuff, it was easier. Okay. And the other thing that business will say too, you also get into leap years where you could have 366. So that can cause some problems a little bit. So in general, we've just been using 360. historically, okay? You also got the leap year thing that comes into play in that too, okay? So that's why. Okay, so we're going to go down and we'll do this one example. We're going to do this on the graphing calculator, and I'll show you kind of what to do on this. So in this particular problem, it says $1,000 is invested. One thing that you want to do is you want to write down what everything means. So that's the principal. So you want to write down P is $1,000. So that's what you're depositing into the bank. Okay, the interest rate is 9.5%. So what do you have to do at the interest rate before you plug it in the formula? So you got to move the decimal to the left too, okay? So you want to write that as 0.095. Don't forget to do that or you'll get crazy answers, okay? And then it says annually, okay? Well, annually means that M would be 1. We'll write down the formula here in a minute and show you how to do that. And then the time is years, so T would be equal to 4 years, like that then, okay? And then what we're going to do is we're just going to do this kind of, we're going to do a table and do this on the graphing calculator because it saves basically a little bit of time on this then. So what I want to do now is over at the side, you can write this down somewhere, the compound interest formula at the top of the page goes like this. So it's A, that'll be the amount after interest, is the principal times 1 plus I, and then that would be, they use, I think, N in this. I want to match the same variables that they use in the textbook then. So we're going to get everything plugged in. So it goes like this. First of all, the principal is $1,000. Okay, that's what we put in. So that goes there. Okay. Then remember in this formula, you got to understand what the I is. I is the interest, which is 0.095, and then divide by M, which is, since it's annually, you put a 1 there. If it was quarterly, you'd put a 4 there. If it was monthly, you would put a 12 there, and so forth, okay? Now what we're going to do on this one, though, is, since we're going to do this on the graphing calculator, we're just going to put, I'm just going to have you put an X there because we have to do this on the graphing calculator, okay? So I'll write on here what you want to put in the calculator, and we're going to do this table so it makes it go a little faster for us. So in your calculator, you want to put this, and I'll bring my calculator up in a minute. In Y equals, you're going to put in 1,000 parentheses, 1 plus 0.095 raised to the X power. Okay, like that. And then I'll give you a viewing window on here to do. I'm just going to have you write down this viewing window. Since we're only going up to 4 years, we're going to go from 0 to 4, scale by 1, and then the interest, since it starts at 1,000, let's go start Y at 0, and then Y max we want to go to 2,000, and then scale by 500. Okay, and you'll see what I'm getting at on this problem. We're going to kind of create a balance sheet on this, and it actually is just as easy to do this problem with a graphing calculator, right? So let me bring this up. You can just do what I do. If you got your calculator, please do this with me. So we're going to go to Y equals, put in this exactly this way, put in 1,000, that's your principal, times 1 plus 0.095, okay, like that, and then close the parentheses, and then your exponent key, remember, is a little caret key, so you can go like that and put in the X like that, okay? So that's what I want you to graph, and what that's going to do is X is going to change, you know, from year to year. So it's going to go like this. Now your window, I'll try to slide these over so you can kind of see what I've put in. Okay, so you want to get that put in, and then just put the window that I have there. So on the window button, we're going to go 0 to 4, because we're going up to 4 years by a scale of 1, and then 0 to 2,000, this is the amount of money. So we're starting at 1,000, and we're going to grow from that, and then maybe scale by 500 like that. Then I'll have you just graph. Okay, so I'll move this over here. I'll get my calculator right back up there in just a second. Okay. All right, so go ahead and graph it. and you should have this. Now what that is that's a picture of your money. So what's happening on this is that's $1,000, and over time your money's growing because of the interest. So this would be like in 1 year, 2 years, 3 years, 4 years, like that. So we can use the calculator to figure this stuff out. So let me show you how we're going to do this then on this particular problem. All right, so what we want to do is we want to do this. Just put in the first year is 0, 1, 2, 3, 4, like that. And we do interest at the end of each year and then add one more line to it like that. This thing is just not behaving. Let me close this calculator because something's going on it. Now what we're going to do is we're just going to look at our table of values. There we go. Now it's working. Okay, so what you can do next is you can go second graph to get the table of values to come up. And so then what we're going to do is we're just going to record these values right here. So you should be able to see on your calculator. So the initial, of course, we start with $1,000. So at the end of the first year, we're up to $1,095. At the end of the second year, we're up to $1,199. At the end of the third year, we're at $1,312.9. And at the end of the fourth year, we're all the way up to $1,437.70. Okay, like that. All right. So one of the benefits of doing a graphing calculator, and like in business and stuff, you'd probably be more likely to do this like on an Excel spreadsheet or something like that. Then it can quickly see our balance at the end of each year. Okay. So the other thing I want to just see if you can do in your head is this. Remember, you started at $1,000. So at the end of the first year, how much money did you make off of interest? How much? 95, right? Okay, you take the 1,095 minus the 1,000, so you gained $95 in interest. Okay, so you can do this all in your head because the 1,000's pretty easy to work with. How about at the end of the second year? How much money did you gain? 199, right? So we start with, and you don't have to write all this out because you can do this in your head. So you've got $199 there. And then after the next one, by the same logic, you would have made $312.90. And by the end of the fourth year, you would have made $437.70. Okay. Now notice that it's gaining momentum. So what happens on compound interest is it's not 95 more each year. It gets bigger, doesn't it? Okay. So it's a curve. So if you look at your graph wasn't a line, it's a curve. So what will happen is over time, you gain more and more interest. So it follows kind of like an exponential function. Okay, does that make sense? Okay, because what you're doing is you're basing the next interest on interest you've already earned. So it gains and it keeps increasing. And what will happen is if you go down and start looking at, once you get down, look at 10 years. At 10 years, you're up to $2,478. Okay, so you've gained a lot of interest. Your money's more than doubled at that point. Okay, so that's just something I wanted to show you visually how that works. Any question about that and what we did on the calculator? Okay, all right, so we're going to go to the next page and we'll do just a little bit of number crunching on a few things here. So the key thing is when you're doing these problems, know what you're given and know what formula to use. So let's read this and see kind of what we have here. So this says a newborn child receives a $40,000 gift towards college from her grandparents, nice grandparents. Okay, so $40,000, we're going to find out how much it will be worth in 25 years if it's invested at 4.58% compounded quarterly. So we're just going to identify everything that we need to know in this formula. So the compound interest formula is P times 1 plus I to the n. The amount we don't know. That's going to be how much after interest we're going to gain. The principal, what's that? 40,000. That's what we're putting in. Now the interest, remember in this formula, I is R over M. All right, so you got to move the decimal back 2 places to get 0.0458. Okay, now what's quarterly? That's 4. So we divide by 4. So that's what goes there then. That's because of the quarterly. So it's always the rate divided by the number of times you do compound interest then. Okay, now N is just the total. Whenever you look at N, you always do this. You do M times T. So it's the total number of times that interest is done. So think about it this way. You can do this in your head too. Interest is done 4 times a year for 25 years. So how many total times would interest be done then? 100, right? Okay. So what you would go here is you would compound 4 times for 25, so you'd get 100. Okay, that's a grand total. That N in that formula is the grand total of how many times you compound interest. Okay, now when you put this together, you want to write this down like this. We just say A is 40,000. Then we have a set of parentheses, 1 plus 0.0458 over 4. Just let the calculator do that for you. And then that would be to the 100th power, like that. And then we go directly to the calculator, and you can pretty well do these problems, every one of them, all in one step, see. Okay? So you want to just go to a clear screen, put this in with me, and see if you don't get the same answer. So 40,000, parentheses, 1 plus 0.0458, and divide by 4 because it's quarterly. Close parentheses, raised to 100. Remember, that's 25 years, 4 times a year. Okay, so let's see how much money you got for college now. Holy cow, look at that. Okay, does that surprise you that it's that much? Yeah, that would pay. That'd pay a lot though. People these days are getting in serious debt with student loans. One of our presidential candidates is proposing that we forgive all debtness. I'm for that. Totally. Stimulates the economy, don't you think? Okay. I believe that education should be something that we don't base on how much money you have. I think everybody should be open to an education.
Universities.
What's that? Same thing. Same thing. Same thing. And the thing about it is, what's happening is students are getting out of college with so much debt that it's like buying a house. Okay, if you had loan forgiveness, if it was possible to do that, then those graduates could put their money into the economy and so forth. It's a reasonable idea, you know. Of course, the question is, how do you pay for it? Yeah, yeah. Oh, I'm all for minimum wage being raised. Minimum wage is not kept up with the cost of living. I'm not even close. So I'm totally for that. Okay, so anyway, that would be the amount of money. You've gained a lot of interest. That's because that loan's going out for 25 years, okay? So if somebody was saving for their kids' college and an annuity or something like that, you start early, and then you start gaining a lot more money in the long run. Okay? All right, so is that working okay for everybody on the calculator? Just put it in one step on your calculator like that, and should give you the same answer. You just got to make sure you have the parentheses, use your keys correctly and everything. What's that? I think I'm okay. Did the rest of you get what I got up here? Are you sure? I don't know. Look, Mike, did you put 100 in for your exponent? Yeah. And you got 0.0458 over 4? Yeah. Let me see your calculator real quick. I can tell you. It's got you did something. Try to put it all in one step instead of doing it in individual different steps, because the rounding can cause significant problems. So try to put it in exactly the way I did there in one step. And you have, is that an 83?
Yeah.
Okay, it'll work. Okay, just try it that way, and I think it should be fine. Okay. All right, so let's look at the next one then. Now, this one says you're depositing $12,500 in a savings account now. What rate compounded continuously? So when you see the word continuously, then you have to go to this, I always call it the PERT shampoo formula. That's how I remember it. So PERT, okay? And it would be how much would be required for you to withdraw $15,000 at the end of 5 years. Okay, so what you're doing is you're looking for an interest rate. Now you're going to start doing solving equations. So the amount, which is the amount? Is it 12,500 or 15,000? How do you know? Because it's bigger. Yeah, it's a withdrawal at the end. It's bigger. Okay, that's after interest. Okay, so you want to know, be able to tell the difference between the two. The principal is 12,500. The interest rate, you don't know what that is. Okay, and then the time on this, it says at the end of 5 years. So it will go like that. Okay, so what we're going to do is I would start by just writing down the continuous compound interest formula, and then we need to just get everything plugged into it. Okay, so what you would have is the principal, the amount is 15,000. So you want to plug that in. The principal is 12,500. Then you have e to the r. So you're trying to find the interest rate, so leave that alone. And then the time is 5 years like that. So you want to get everything set up like that then. And what you can do on this is we have to work with an equation. I'm going to put this kind of over the side here so I can take up a little bit more room. So it's 15,000 equals 12,500 times e to the 5r. So that's how that's set up. Now, here's the thing that you got to pay attention to. Write this down if you need to. If the unknown is in the exponent, then you have to use logarithms. Okay, you'll get used to seeing me do that because we do that all the time. So you have to do a logarithm of both sides to do this. And once you learn how to do that, it's not that hard to do. So the first thing you want to do before you do the logarithm is you want to get the e to the 5r all by itself. So we're going to do this, okay, like that. I think I got added an extra zero in there I didn't intend to, okay? All right, so we're going to do that. And you can go ahead if you want to and use your calculator to do this value right here. You can wait till the very end. I usually wait till the very end. Let's go ahead and do it this way, though, for now. But just use all the decimals that come out on your calculator. So I'm going to do 15,000 divided by 12,500. That'll give a decimal. Okay, that's good. It didn't have that one terminated. So you get this. Okay, that's how you have to start that. Now you're going to do a logarithm of both sides. And you're going to use an ln because that's got an e in it. So the next thing you want to do is do the natural logarithm of both sides. Okay? All right, now the logarithm thing, what you have to know is we learned a property. Let me see if anybody remembers this or not. Do you remember what you're allowed to do with the exponent? It's super important. Yes, you bring it down. You'll see me do this over and over again. This is probably the main reason that you learn about logarithms, because in finance, you have to learn how to do this then. So what you want to do is bring down the 5r in front of the lne. If you don't know what lne is, it's 1. You can use your calculator, so you could actually go like this. You could go, there's your ln button. The letter E is above the division symbol. So you could go ln, second division symbol to get lne to come out. That ln of E is going to show up over and over again, so it's good to know that it's 1. So you would get ln of 1.2 equals 5r now, because that thing right there just gives you 1. Okay, like that. What's that? ln is in the first column. See where the log is? There will be log is base 10 log and ln is base e. You find it? Right there, just ln, just press ln, okay? And then E is above the division symbol. So if you go second division symbol, that's how you do ln e. So it's like that, okay? All right? Okay, one more step. What do I need to do to both sides of this equation to get rid of the 5? Divide by 5. Okay, so I do that. Now I go to my calculator. So you now want to do this. You want to go ln of 2, or 1.2, sorry, like that, and then divide by 5. And we'll just write down whatever comes out. A whole bunch of decimals are going to come out, so you're going to end up getting 0.036464311. We are going to round this, so that would be your interest rate like that. Now, that is what we call a decimal interest. So what if I wanted a percent interest? Then what do? Then you move it to the right 2, so you get like 3.6, okay? So that would be a 3.6% interest rate. That would be the answer to that problem. So you would end up getting R is about, we'll just say 3.6. We just round that off like that. Okay, now what you're going to do, what I find students a lot of times don't have too much trouble when you just plug in the formula like we did the first one, but a lot of times you're going to have to solve equations with logarithms. And the reason you're going to know to do that is if the unknown is in the exponent, that's what's going to tell you that you have to go through this methodology. Does that make sense? That's one of the reasons you learn logarithms. You don't know logarithms, you wouldn't have any ability to work that out, okay? And you want to be able to work these formulas out in all kinds of different ways, okay? Does that make any sense, what I did? Calculator, everybody see where everything is on the calculator? You find it, Corey? Okay, very good. Okay, so I'm going to do a couple of other things here. And these, on this example 4, you're going to use logarithms again on this. So this says, how long will it take money to double if it's invested at 7%, okay? Now, that doesn't have anything to do with the continuous compound. It has to do with the compound interest formula because that's what it says. It says compound daily, okay? So I would start by writing down this compound interest formula. You can use the one that I taught you in 3.1, and to me it's just as easy to always use this formula. A equals P1 plus R over M to the MT. Okay, I don't know why the textbook shows it this way. To me, that's the compound interest formula. That's the way you always ought to do it, in my opinion, is just do it that way, okay? Now, notice I didn't give any money. I didn't give you how much money, and it turns out it doesn't matter. If you put a penny in the bank, it'll take it the same amount of time to double as it will $1 million. Okay, that's the way it works out. So here's what you're going to do. This is the logical way. Just choose P to be $1, and then A is going to double to $2. It says how long does it take it to double. So I don't have to give you those amounts. You can choose whatever you want to, but it's just as easy to do 1 and 2. So when we set this up, A will be $2, P will be $1, and then we're going to plug everything in. Okay, so we have the interest rate, 7%. So move the decimal to the left 2 to get 0.07. Now it says compound daily. So what's M? 360, good. Okay, we're going to use a 360-day year. That's common business practice. So we do that, okay? In the formula, M is 360. We don't know what T is, so you leave that alone like that. So again, what I'm doing is I'm just choosing that to be $1 and it doubles to 2. If I do a triple problem, that'd be 1 and 3, right? It doesn't matter what you choose, just don't choose 0 for P. But if you can choose anything you want to, okay? All right, so what we're going to do on this then is I'm going to write this like this. The 1 is really no longer necessary because if you multiply anything by 1, it gives you the same thing anyway, okay? So you can go like this. If you want to, you can wait till later when you do this. So what I'm going to do is just not do anything inside the parentheses, just leave that alone. And then we're going to take the logarithm of both sides. Why am I doing the log of both sides? What did I tell you that you have to look for? The unknown is in the exponent. That's why I know to do this, okay? So what I do is I do ln of both sides, and you'll see me do this enough, you'll get this down, so you'll get used to doing this. So we have ln2 What did I say you can do with the 360t? Comes down. That's the whole key. That's the purpose behind the logarithm here. So you end up getting 360t, okay, and then you're left with the logarithm 1 plus 0.07 over 360 like that. Okay, so that's how that goes, all right? So what you're doing now, and so it only takes a couple of steps, the rest of this you do on the calculator, you want that t to be by itself. So what you do is you divide by this whole thing, 360 ln 1 plus 0.07 over 360. You do that to both sides of the equation. That'll get t by itself. Then you go to your calculator. And I'll have to show you something on your calculator because students a lot of times do not do this last step right on there, okay? So what you're doing is you're ultimately going to put this in your calculator, all right? See, what I did is I divided by 360 ln to get the t by itself. Now on your calculator it goes like this. Watch this very carefully because you don't want to mess up on problems just because you don't know how to enter it in your calculator. So you have ln2 divide by. Now this is a big deal. Make sure that that denominator is in one giant set of parentheses, because if you don't do that, the calculator won't do this correctly. The calculator's got to do that denominator before it divides. So go 360 like that, and then you can put in your ln key and then 1 plus 0.07 over 360. And then you got to double up on the parentheses like that. See, the thing that you have to understand is the calculator has to do this before it divides all that stuff. And if you don't put those parentheses, the calculator will do this. It'll go ln2 divided by 360 and then times the ln, which is totally wrong. So you have to have that in a set of parentheses. Then when you put that in, there's your answer right there. So the time would be about 9.9 years. Okay, so that's how long it takes that money to double after you put that together. Okay, now that's what you'll get into in these kind of problems, is working with logarithms. Again, that's one of the reasons why we learned that. Okay, you guys follow that okay? You follow the 1 and 2, why I did that? Okay, it's a double problem. That's why you have to choose something for p and then double it. Okay, next one we'll do the same way. Now this one says continuous, so which formula do I use? The PERT formula, right? Okay, all right, so write down the PERT formula. Okay, so we have A equals PE to the RT, and it's the same problem. It's how long will it take the money to double? So again, you can pick anything you want to for P, but it's just as easy to use 1 and then double it to 2. Same idea. This would be E, and then the interest rate was 0.07, then we have T like that. So usually these kind of problems right here look a little easier to students because the formula is easier. So what you get is you get 2 is equal to E to the 0.07t. The reason I like to use 1 is because now you don't need it anymore, see? Because 1 times anything is itself. So now what you do is you do the natural log of both sides, like that, and then that allows you to bring that exponent down in front, like we've been doing. So you would get ln2 equals 0.07t times ln e. Okay, did you all catch on to what I said ln e was a minute ago? What's that? Oh, I put the wrong thing in. I'm back on the other problem. Okay, thanks for noticing that. So that is 0.082. Thank you. So I changed the interest rate. All right. So yeah, that was 0.082. Then you bring that down in front, so now you'll have that then. Okay, ln e is 1, so you can really just mark that out. Okay, ln e is 1, so it doesn't have any bearing on anything. So what you end up getting then is ln2 is equal to 0.082t, right? What's the last step before you go to the calculator? Divide by 0.082. So you're solving an equation, then you go to the calculator. So we divide by 0.082. both sides, and then just round it off. That'll give you the amount of time. It's going to be a little different. Answering the last one's different problems. So this is, we do ln2, be sure you close parentheses on that, and then divide by 0.082. Yes? The lne, that's 1. lne is 1, so if you multiply 1 times 0.082t, you get 0.08t anyway. So you can just sort of ignore that because it's 1. You don't have to show that step necessarily. Okay, so what we get then is we would get we'll just round that to like 8.5 years is how long it takes that money to double in value. No matter what it is, even if it's $1 million, it'll still take 8.5 years for that money to double. Okay, that's the idea. Okay, does that make sense what I'm doing? Okay with the log? Okay. Right? So let's work out, we'll just kind of do these next two together here. I want to get through this, and then the other thing we talk about is an annual percent yield. Okay, so this one, let's get them set up, and I'll let you can kind of finish these on the calculator. So the first one says you deposit $50,000. It says at what rate, so you're finding R, so R is the unknown. It says continuously, that's why you use the PERT formula, all right? And then it says you're gonna end up with 75,000 in 15 years. Okay, so which is A and which is P? What's A? Good, okay, what's P? Okay, so you always want to know that. A is the bigger number in this case. That's after interest. So A is 75,000. P is 50,000. We don't know the interest rate, so leave that alone. That's your variable. Then the time is 15 years. Okay, and I'll just do this at the side. You should have enough room to do this. So when you plug this in, you would have 75,000 for A equals 50,000 for P. And then that would be e to the r times 15. Now you can just write that as 15r if you want to, like that. So the unknown is r. Okay. All right. Do you have to use logarithms on this problem? Yeah. How come? Because the unknown is in the exponent. Okay. All right. Well, before you do the log of both sides, you want the e to be by itself. You got to isolate that e. So you have to start by dividing by 50,000. You have to do this in a certain order, like that. Okay, and then you can take your calculator and we can just work this together. So if you go 75,000, you can even do this if you want to. You can cross those 3 zeros out. Okay, so you can just do 75 divided by 50. And I would always write down whatever decimals come out on your calculator, because if you round early in the problem, it'll affect your answer later. So that's 1.5, and now we have e to the 15r like that. Okay? All right, now I'm ready to do the natural log of both sides. So you want to go ahead and now do ln of both sides. All right, so what we'll end up having then is ln of 1.5. Just wait till the end on your calculator. You'll bring the 15r down in front. So you get 15r times ln e. Okay, I'll keep asking this until everybody knows it. What's ln of b? 1. I'll keep showing up over and over and over again. So that thing you can just sort of cross out. It's not that it's dividing out, it's just 1. Okay, that's why. So now what we end up having is ln 1.5 is equal to 15r. All right, then what's the next step? Divide by 15, then go to your calculator. And what you'll get is you won't get a decimal percent, so you'll have to move your decimal over to get that decimal percent. So now we just go straight to the calculator, and you want to do natural logarithm of 1.5, close parentheses, divide by 15, and that will give about, and you don't have to write all those decimals out, just enough, because generally you're going to round anyway. So if you move that over 2 places, you would get the interest rate is about 2.7% as your answer to your problem then. So that's how that would go. Okay? All right, does that look okay? Shake your head or something. Okay. Okay. I've done a bunch of those. You're going to use logarithms quite a bit in this section because you have to solve equations. That's why we're doing that. Okay. Okay, so let's see. The next one here, let's set this one up and see if we can put this one together. Okay, this says, how long will it take $100 to double in value at 5% compounded monthly? Okay, so what's the principal and what's the amount? Can you tell me that? What's the 100? Is the 100 the principal or the amount? That's what you're starting with. Can you tell me what A is? I didn't give it to you. 200. How do you know? Because it doubles. So see, you figure that out. Okay. All right. Now, what is M? If it says compound monthly, then what's M? 12. Good. So I is R over M. So we do 0.05, change that to a decimal percent, and then divide by 12 like that. Okay. Now, what we'll do on this then is the N. Really what N is it's always the number of times you compound times the time. And what you're doing is you're finding the time. Okay? That's why I prefer that you guys just use this formula all the time. To me, that's what I always do is just use this formula. You don't have to use the formula that they gave you. It's the same thing anyway. To me, it's just as easy to do it that way. Okay? So now when we plug this in, we'll have, and I'm going to plug into this formula over here, we would have 200 is equal to 100, and then parentheses, 1 plus 0.05 over 12. And then when I say MT, M is the 12 for the compounding, then you have T like that. Okay, that's the way I'd set that up, is like that. And then we'll solve that. We have to use logarithms on this also. So I'm going to do the work over here at the side. I think you got enough room in your handout there, though. And what I like to try to do as much as I can is try not to do any rounding until the very end of the problem. So the first thing you have to do before you do a log of both sides is you want to get rid of that 100. And when you do that, you'll get 2 is equal to this raised to the 12t like that. So that's how that gets put together, is like that. Now you're ready to do logs of both sides, okay, like that. And see, the reason that I don't even have to give you the $100, because you would end up with 2 anyway, okay? So now I'm going to do the log of both sides. So I'll do the log of 2, and then I'll do the natural log 1 plus 0.05 over 12 to the 12t. And again, you can move that 12t down in front like that, okay? And what you're trying to do is you're trying to get t by itself. And what you're really doing is you're dividing both sides by 12 ln, 1 plus 0.05 over 12. Both sides, then go to your calculator. And again, don't forget on this problem to make sure that that denominator is in a big set of parentheses like that. So just for emphasis, I'm going to put a big parenthesis there. That's how you want to put that in your calculator. If you don't do that, it won't calculate it right. Okay. So then I'll put it in. You can put it in your calculator, see if you get what I get. So do ln2 divided by, and then parenthesis, 12 ln 1 plus 0.05 over 12. Then double up the parentheses at the end like that. So that's how that has to be put in your calculator. So that you would end up, after all that cancels, you would have the time is about, we'll just say about 13.9 years. So that's it. Okay, so that's how that gets put together. So it's a matter of knowing which formula to use, and then anytime your unknown is in the exponent, you have to use logarithms to solve that. Okay, you guys with me okay? Everything I'm doing? Calculator's working okay? Okay, all right. All right, so I'm going to show you, I think, one more thing. Mostly in this section, you're going to use the logarithms quite a bit. The 3.1, you don't do that at all on the compound interest formula. All right, so I'm going to give you these two formulas for annual percent yield and kind of tell you what this is. So what this is really doing, what an APY is, and you hear about this a lot in in banks and savings accounts and so forth. It just means the amount at simple interest after 1 year is when it's equal to the amount at compound interest at 1 year. So you can change a compound interest to sometimes we call that an effective rate, and it would give you the same interest as if it was simple interest after 1 year. So a lot of times you use this to compare interest rates, okay? And I'll show you an example of that in just a minute then. So the formula, if you'll go to the next page, you just need to know the formulas. So the formula for compound interest is this. I'm not going to go through the derivation of that. So that's the annual percent yield if it's compounded. And then if it's continuous compounding, then the APY is e to the r minus 1 like that. So we're just going to do one illustration of this. And I think this thing I took out of the book will show you kind of what you're using this for. The idea is if these are CDs. So like, for instance, if you saw that you had different interest rates, it's a little hard to tell which one's the best just by looking. That's 4.93, but it's monthly. That's 4.95 daily. That's quarterly, and that's continuously. So it turns out if you change these to the APY, then it's real easy to tell which one's the best and which one's the worst. Okay, so that's what we're going to end up doing on that. And we're just going to work these things out. Now, I've already taken this out of the book because I don't want to spend all the time doing this, but let me show you basically how this goes in the formula then. So the Advanta is 4.93. So the formula for APY is 1 plus the interest divided by the amount compounded, 12, to the 12th power minus 1. Okay, so then I work that out, I get like 5.043, like that. Okay, deep green, okay, 4.95. So it's 1 plus 0.0495. This time I went ahead and did a 365-day year. Plug that in the same way I did there, I got 5.07. That's a little higher interest rate than that is then. Then I did charter one the same way, that's 4.97. Quarterly plugs in like that. Does that make sense to everybody how everything's plugged in? Okay. Then you just do the arithmetic on your calculator, so you get that. And then the last one is continuous, so it's that formula up there. So you end up doing e to the 0.0494 minus 1, so you get that. So now if you look at these, which one's the highest interest rate? This one is, okay? So deep green is your best bet. It's kind of hard to see. I would probably know that because of the daily possibly from doing that. Yeah?
How come for that one they're using 365 instead of 360?
Just a matter of choice, okay? In general, just kind of, it depends on that, you know, so sometimes 360, a lot of times we do. I think a lot of times in APY, 365 is used because you're only doing that one time, so you're not worried about leap years and stuff like that, okay? That's a good question, though, so that's, I think, why you're doing that. Okay, so anyway, what would happen is you would end up with this. That would be the best, and the lowest, I guess, would be this one. That would be the worst, okay? So like that. So you can compare interest rates by doing the APY. That's the purpose behind that. Okay, let's do the calculation on the next page here, and that'll wrap this up, and then we'll take a break, okay? All right, so I want to just do a little bit of these and give you a chance to set these up and use your calculator to get these. Okay, so what we do on this one is, this one basically, there's only two things you have to know on the APY formula. The interest rate would be 0.0432. Compound monthly would be 12. So you just plug in and go to your calculator. So you would go like this. The APY, annual percent yield, would be 1 plus 0.0432 over 12 to the 12th power. Okay, just do exactly what the formula tells you to do. And we're going to go directly to the calculator and see what we get here. Okay, so you can just go parenthesis 1 plus 0.0432 over 12, close parenthesis, raised to the 12th power, and we'll just round that off like that. That will be R is equal to 1.0. We're just going to round these things to 2 decimal places as we go through like that. Okay, so that way you don't need to move the decimal over anything, just leave it alone. In the formula, we just leave that alone. Okay, and then the next one, I'm saying to use a 360-day year on this one. So this one will be daily, so we'll use 360. The interest is 0.0431 like that. Okay. What's that? Oh, did I forget the? Oh, I forgot the -1.
Yeah, correct.
Yeah. Okay, I didn't write that on there. Thank you. That is -1 on both formulas. So I got to do the -1 on that. Okay. Remember, if you look at the previous page, there's a -1 at the end of that. So you would end up with, after you subtract 1 from that, you get R is 0.04. And I probably should take that out and use those decimals. Then you can move that to the right to get your percent would be about, you could round that to about 4.07, like that. Okay, if you look at the previous page, see, I wrote the formula down wrong. Its APY is 1 plus R to the R over M to the M and then -1.
Right. So when you say R is equal to, are we looking for R?
What's that?
Are we looking for R or what?
I'm sorry, I'm not sure.
The final answer is R is equal to something, right?
Yes.
Why R?
Well, I want to go ahead and, not R, APY. That's a good, yeah, okay, APY is what I'm doing. I mean, it's an interest rate, but you want to call that the annual percent yield. Okay, all right, and then this next one goes like this. We would have the APY is equal to 1 plus 0.0431 over, and this is daily, so I'm saying use a 360-day year to the 360 power, and then you got to do the -1. Okay, you got the -1's a part of the formula. So then just do one step on your calculator if you want to. You'd have 1 plus 0.0431 divided by 360. And then that would be raised to the 360. Get out of the exponent, subtract 1. That's how you do that in one step like that. And that will give you about 0.0440396. You don't have to write all the decimals out, because what I'm going to do is just change that to the APY is about 4.40%. So the higher interest rate on this one would be the second one. Okay, so that's how you get that then. Okay, does everybody see how that formula goes? Okay, there's nothing to it really. Okay, I want to make sure I've got the right formulas on these. So go ahead and just do the next two yourself. Set it up, go to your calculator. We'll see if we get the same answers. Now this is continuous. So you would say APY is e to the R minus 1. And then that second one, you need to put that -1 in there. I think I didn't cut when I was cutting and pasting. Probably just didn't copy that right or something. So put those two in and see kind of what you get for comparison. Now what you're doing on this is you're trying to see out of these two which one would be the better interest rate if you were doing a savings account or something. What do you use for semi-annually, by the way? 2, okay? And on your E, you've got above the division symbol, you can do that. Also above ln, there's e to the x. So I would put this first one in, I would go like this. I would just go second ln. That just gets the e coming up. And all you got to do is put in the 0.0515. Be sure you get out of the exponent, then subtract 1. And that'll give you a decimal rate. Then you can change it to percent. So that ends up giving you 0.0528. Again, I'm just going to round these usually to like 2 decimal places. So you can move that over, and then that would end up giving about 5.28% is what you would get there for your annual percent yield. Okay. And then the next one, just put it in exactly the way it is. 1 plus the rate, 0.0520, divided by 2 for semi-annually. Raise that to the second power. And then out of the exponent minus 1 like that. That'll give you a decimal. So that should give 0.052676. Move the decimal to the right 2. So I'm going to round that to 5.27%. So which one's the better deal, the first one or the second one? The first one's a little better. Okay. What's that? Yeah, it's not a big difference, but it is somewhat of a difference. So that's the idea, is what you're doing is if 2 interest rates are real close to each other, you can use the annual percent yield to compare the two. Okay, does everybody understand the formula, how that's set up and everything in there okay? Yep. What's that? Yeah, like if it was a savings, if you're saving money, it is. If you're buying something, like if you're buying a car or something, that's better if you go with the lower one like that. So it kind of depends. Most of the time on these, you're looking at savings or a CD or something like that. Okay. Right. Any questions about that? Okay. It's not that hard. It's knowing the formula and then knowing what to do with it and using your calculator. All right. Let's take a 5-minute break.